Okay, today we're looking at section 7.8, which is the last section of chapter 7, and it's talking about geometric sequences. So hopefully by the end of this lesson you can say that I can write and use recursive and explicit formulas for geometric sequences. So first of all, sequences again. We have studied arithmetic sequences in chapter 4. Arithmetic sequences would be like the example we have here where we have 1, 4, 7, 10, where we're repeatedly adding, in this case, or subtracting the same amount. So we can see here that we're adding on 3. Here we're adding on 3. Here we're adding on 3. So we're repeatedly adding on 3. Okay, today we're going to start looking at geometric sequences. And geometric sequences are where we're repeatedly multiplying or dividing. So here we multiplied by 2. Here we multiplied by 2. Here we multiplied by 2. So how do you find that 2 part? Well, it's the ratio of, for instance, the second number divided by the first number, or in this case, the 12 divided by the 6, or the 24 divided by the 12. It's the common ratio, we call it. Okay, and we looked at a similar thing when we were looking at exponentials a couple days ago. Okay, so we need to determine whether the sequence is a geometric sequence. So again, we're looking for that common ratio. So is there a common ratio on number 1? Am I multiplying by something each time? And hopefully we can see that if I took 4 divided by 1, I'd get a 4. 16 divided by 4, I'd get a 4. 64 divided by 16, I'd get a 4. So yes, it is geometric. And how would we know? Because it has a common ratio between terms. Okay, how about this next one? If I took a look at number 2 and I did the same thing, 108 divided by 36, we would get a 3. 36 divided by 12, we'd get a 3. And a 12 divided by 4, we'd get a 3. So in this case, yes, again, oh, let me back up. Okay, I divided those in the wrong order. I should have said a 36 divided by 108. That is 1/3. A 12 divided by a 36 is a 1/3. And a 4 divided by a 12 is a 1/3. So our common ratio that we'd be talking about is a 1/3 in this case, since we're decreasing. Okay, the next one. If I look here, 15 divided by 5 is a 3. 25 divided by 15 does not equal 3. So we would say that this one is not geometric. This one was a yes. Okay, and then the last one, number 4 here. If I take 75 and divide it by 60. Again, got that wrong in the wrong order. The second term, 60 divided by 75. Is that the same thing as 48 divided by 60? Is that the same thing as 38.4 divided by 48? So if we use a calculator, 60 divided by 75 gives us a 0.8 or 4/5. Okay, if I take 48 divided by 60, that does give us 4/5 again. And 38.4 divided by 48, again, that gives us 4/5 or 0.8. So yes, in this case, this is geometric because, again, we have that common ratio. Okay, so here is something you may want to take some notes on. We're going to write a recursive formula or definition and an explicit formula or definition for these geometric sequences. So we're going to take a look at a few and see what we can do with them. So if we tried to find, first of all, just that common ratio again. So from 2 to 8, and then 8 to 32, and then 32 to 28. So to find that ratio, second term divided by the first one, or the third one divided by the second one, or the fourth one divided by the third one, and we'd still get that common ratio of 4. So our common ratio is 4. So for this one, if we know that it is geometric to start with, all you have to do is take one of them. 150 divided by 15, our common ratio is 10. Okay, if we take a look at this one, our common ratio, -2 divided by -2, happens to be a 1. So our common ratio here is a 1. And for this last one, if I took 81 divided by 243, you should find that that is a ratio of 1 to 3. Okay, Very good. Let's continue on. So if I asked you to write the explicit formula, so you may have to look back at your notes that you were taking, the explicit formula, we would say that AN is equal to our first term, which is a 3, times our common ratio. Well, our common ratio, 6 to 3 is 2. 12 to 6 is 2. So our common ratio is 2, and then it's always going to be to the n minus 1 power. So there would be my explicit formula for this sequence. Okay, if I look at my next one, a negative 5 divided by a negative 1, or a negative 25 divided by a negative 5, our common ratio here is a 5. So what's that going to look like? It would look like this. AN, or any term, would be found by taking your first term times your common ratio to the n minus 1 power. Okay, let's continue on. So now for this one, I got 70 divided by 140, or 35 divided by 70. The common ratio here is a 1/2. So how does that show up? Well, I would start again like so, and I'd have 140 times our common ratio, 1/2 to the n minus 1 power. Okay, and then my last one, I've got a negative 24 divided by 12, or a 48 divided by negative 24, and we do get a ratio of a negative 2. So my explicit formula would be AN is equal to a 12 times a negative 2, and if it's the ratio is a negative, you need to put it in parentheses, negative 2 to the n minus 1 power. Okay, and then the last thing we're going to see today is what about a recursive formula? A recursive formula is this one that we had 2 steps to. So this is where we have one term, first term for instance would be a 1, and then any term after that, if we're thinking of it a recursive formula, you take the previous term and you times by the common ratio. In this case, 7 over 1 or 49 over 7, our common ratio is a 7, so we'd be timesing by a 7. Okay, so this next one, our first term is a 5. Any term after that, you could be taking the previous term, the n minus a to the n minus, or parentheses n minus 1. This again refers to the previous term, and then our ratio here, 10 to 5 or a 20 to 10. Common ratio is a 2, so we'd be multiplying by a 2. Okay, so if I looked at this one to try and find my common ratio, you got to take these things and divide them out. So 384 divided by 512 is 0.75, which you could also write as 3/4 if you wanted. We'll use 0.75 for this one, just to show you a different version. 288 divided by 384, we again get that 0.75. So how would I write this one? I would write it as our first term, again, is 512. Any term after that, you take the previous term, and you'd have to multiply by a 0.75 or 3/4. Okay, so then I want you to pause the video, and I want you to see if you can do this last one. And what you should have found is that it would be this. First term is a positive 8. Any term after that, you would take the previous term, and you would times by a negative 1. Okay, so hopefully things are somewhat clear. Again, we can come with questions tomorrow. That would be great. Okay, that is a wrap.